Okay, last question. An AC source of 10 volt RMS and frequency 50 Hz is connected to a circuit which consists of an inductor of inductance 2 Henry and a resistor of 1 kilo ohm. So we have to determine the current flow in the circuit, voltage across resistor and inductor, as well as the phase angle between the applied EMF and the current. Okay, so firstly, the current flow in the circuit is equal to V over dz. Okay, so we need the impedance before we can calculate the current. So impedance is R plus XL square here as well. So we need the inductive reactance, so that is 2 pi FL. So we get this and then substitute into here, so we get the Z, and we will then plug that value into the equation here. So you will then get the current. So the current is going to be equal to 8.47 milliampere. Okay, right, and then the voltage across the resistor and inductor is basically just VR equal to IR and VL equal to IXL. Okay, so the current is the same because they are connected in series. Okay, so this is going to be 8.47 volt and this one's going to be 10 volt. And then the phase angle pula. So the phase angle is gonna be shift tangent XL over R. So this is gonna be 32 degree. This is actually phi. Okay, so you will get 32 degree. Then question B, what should you do so that the voltage of the circuit is in phase with the current? Okay, so this is an RL circuit, so it will not be the voltage will not be in phase with the current. But what we can do is by removing the inductor. Removing the inductor will cause the voltage to be in phase with the current. Okay, right, then question C, draw graph and explain graphically the dependence of R, X, C, XL, and Z on frequency. Okay, so that graph is the one yang ada banyak line tu. So this is frequency, this is X, C, XL, R, and Z. So firstly we have R, and then we will have the XL, and then we have the what else? We're gonna have the Z. The impedance is something like this, and then lastly the inductive the capacitive reactance, which is inversely proportional. Okay, macam tu lah. Alright. Okay, so what this graph would tell us is there will be a point where they would have a resonant frequency, which is shown bear with me for a few seconds. Okay, so my graph is not accurate. It should be in this one line here. So basically this one should move sini sikit lah. Okay, so this would give us the resonant frequency. Okay, alright, so what you need to know from the graph is just that there will be a point when the frequency of the applied voltage to be equal with the frequency of the RCL circuit. So when that happens, that phenomenon is known as resonant frequency lah. Okay, itu je. Right, so yeah, that is on question number 10.